Right, so I'm back, and so apparently the last video got slightly corrupted because the encoder kind of overloaded, but it's fine. It should be fine now. Let's check the overloader or the encoder. Yeah, the encoder's fine. So let's start again. We'll not start all over. We're just gonna resume. Right. So the namespace works now. That should be that done then. Okay, here we go. So G plus plus RPG start dot cpp wait, it's saying it's missing. Wait, hang on, did I not save this? Save, try again. Paste that. Now there's even more errors. Okay, so the main must return int for some reason. And error, wait, okay, that's fine. Then expected primary expression before response. What? Respond, wait. Let's check how we do strings again. Wait, it's farther up, isn't it? Yeah. So how do we do strings? Can't find it. Hang on, hang on. There it is. That's how you do strings. Compound types, of which fundamental types are mere building blocks. An example of compound type is the string class. Variables of this type are able to store sequences of characters such as words or sentences. Very useful feature. A first difference with fundamental data types is that in order to declare and use objects, variables of these types, the program needs to include the header where the type is defined. Right, so we need to include the string. Okay, so hashtag include string. There. And that should fix that string. Next. Yeah, that should fix that. Okay. Paste. Still broke. Right, I didn't save. No, not save as. Please don't do that. Cancel. Save. Now let's try again. Function, okay. Expected primary expression before response. I don't get it. What's a primary expression? C out string. Okay. But how do we get C in? Or sin? Like you see in the previous example, strings can be initialized with any valid string. Literal, just like numerical type variables, can be initialized to any numerical literal. As with fundamental types, all initialization formats are valid with strings. So apparently you can do this. Epic. Okay. One thing I've seen here is that apparently you need to do this. End L. Right? Isn't that what it is? Yeah. No, inserting end L, manipulate ends of the line, printing new line character, and flushing the stream. String class is a compound type, as you can see in the example above. Compound types are used in the same way as fundamental types. The same syntax is used to declare variables and to initialize them. Return 0. Ah, right. So it does have a return type, but at the end, apparently you need to return 0 for some reason. I think that means exit, basically. Okay. Wait, we need to save this. Maybe that'll fix it, but it probably won't. Expected primary expression before response. Okay. What if we do this? Or actually, if I comment that out and I do new, no, not new. New string. That should work, right? Maybe. Save. And I close down my terminal. No, wait, we need to first of all go there. Hang on. Actually, I'm going to close that down. And if I go to File Manager, Document, C++, RPG, and copy that. CD, paste, go. There we are. Now we're here. And we can G++ RPG, no, RPG start dot cpp. Oh god, a lot of stuff happened. Why did a lot of stuff happen? Right, okay, so apparently you can't do that. Instead, we'll do this. I keep hitting the wrong one. Save. Nope. I keep closing it down. And go there. G++ RPG start.cpp. It worked! Finally! Okay, so that's how the code will now look like. See, we're learning via trial and error. Okay. So now we should be able to run it by. How do we run it? How to run compiled C++ code. Nope, not C file. C++. Oh right, I already hit. Okay, open terminal. Okay, that's fine. Compile using any of the following command. Let me just get a bottle of water. There we go. Just down an entire bottle. Well, half a bottle. Okay. That's fine. That's fine. That's cool. And you open the file. Okay. RPG dot CP. No, it's RPG start. Start. No, I'm wrong. That's not what you do. That's something else. So that's how you compile it. Now for running, you do slash. Okay, so you do CPP and then a dot out. What? I'm not entirely sure how that works. RPG start dot that and I think dot out. I think that's how it works. What the hell is happening? Oh, it's just called a dot out. Okay. A dot out. Command not found. Slash. No, dot slash a dot out. Okay. Dot slash a dot out. It works! Actually epic. Problem is it didn't stay in the loop, which is kind of weird. Okay. We'll try again. Okay, but first of all, we need to add in actually we don't need that, do we? Yeah, okay, we don't need that. Bool go equals true. That's why it didn't work. Save. Now let's recompile it. I wonder if you can recompile it. RPG start dot CPP. Okay, and let's check. Does it make 2? No, it doesn't. Good. Now a dot nope out. Okay, let's see what's going wrong. So find it to live works. Okay. Okay. Okay, so the loop works. Question, can we actually do... Okay, let's do that. It works. Okay, so the program works so far. Epic. So we can take basic inputs. And we do actually need this. And L. Same here. And L. There we go. Save that. So now we can actually run these files. Incredible. Now let's make a good video game, shall we? Okay. So, what shall we do as mechanics? Let's say, okay, you have to fight the random mushroom, right? Okay. First of all, how shall we do this? Should we have just one enemy? Or should we have... Because we can do this in two ways. We can do static classes. Although I don't know if you can actually make static classes in C++. But we can make normal static. We can make normal classes. Let's read on ahead. Let's read on ahead on how to do classes. Okay. So we know how to do that. A structure of program. Constants now. So literals, that's okay. Literal, constant, integer, numeral, that's cool. Decimal, octal, hexadecimal, okay, that's cool. All these represent the same number, 75 expressed as base 10 numeral, octal numeral, and hexadecimal numeral, respectively. These literal constants have a type, just like variables. By default, integer values are of type int. However, certain suffixes may be appended to an integer literal to specify a different integer type. So unassigned, long. Okay. Unsigned int. Wait. Okay. Sorry, I was thinking because the thing is, how do you? I didn't fully understand what it meant by you and like how you can put that other like on the other side, but apparently that works as well. Okay. Default type for floating point numerals is double. Floating point literals of type float or long double can be specified by adding one of the following suffixes. I think I'm probably going to be doing this by prefixes rather than suffixes. Character and string literals. Okay. These are the escape stuff that we've used. So, new line. Carriage return. Okay. Tab, vertical tab, backspace, form feed. Don't know what that is. Okay, what's T? Form T. Okay, no, internally computers represent characters as numerical codes. Most typically they use one extension of the ASCII character encoding system. See ASCII encode for more info. Characters can also be represented in literals using its numerical code by writing a backslash character followed by the code expressed as an octal, or in this case base 8, or hexadecimal base 16 number. Okay. The next character is inserted between the backslash and the hexadecimal digits. For example, for A. Okay. several string literals can be concatenated to form a single string literal simply by separating them by one or more blank spaces, including tabs, new lines, and other valid blank characters. For example, that. The above is a string literal equivalent to this. Cool. Note how spaces within the quotes are part of the literal while those outside of them are not. While some programmers also use a trick to include long string literals in multiple lines, in C++, a backslash at the end of a line is considered a line continuation character, where that merges both that line and the next line into a single line. Therefore, the following code is equivalent to that. We're going to be using that quite a lot. All the character literals and string literals are described above are made of characters of type char. Or character. Okay. A different character type can be specified by using one of the following prefixes. Okay, so these are just prefixes and how to handle all your constant and how much data you want to use. Cool. Okay, 3 keyword literals exist: C++, true, false, and null PTR. Okay. Null PTR is a null pointer value. True and false are two possible values for a bool. Okay. Sometimes it is just convenient to give a name to a constant value. So pi equals that. Constant expressions, okay. When we can then use these names instead of the literals that they were defined to. Okay. Preprocessor definitions. So the hashtags define. Okay. Another mechanism to name constant values is the use of preprocessor definitions. They have the following form. Hashtag define identifier replacement. Okay. After this directive, any occurrence of the identifier in the code is interpreted as replacement, where replacement is any sequence of characters until the end of the line. This replacement is performed by the preprocessor and happens before the program is compiled, thus causing a sort of blind replacement. The validity of the types or syntax involved is not checked in any way. So define. Okay. New line. See out circle. Wait. What's inside? Okay. Circle equal 2 pi r, and that's the circle radius. Wait. No. 2 pi r is the circumference of a circle. Then you have new line. Okay. That's cool. So you can define them here. Okay. That may come useful. That might come in useful. Next, operators. Assignment operator. The assignment operator assigns a value to a variable. This statement assigns the integer value 5 into the variable x. The assignment operation always takes place from right to left, never the other way around. This statement assigns to the value x the value contained in assigns to the variable x the value contained in variable y. The value of x at the moment is executed is lost and replaced by the value of y. Consider also that we are only assigning the value of y to x at the moment of the assignment operation. Therefore, if y changes at a later moment, it will not affect the new value taken by x. Okay. For example, let's take a look at the following code. I have included the evolution of the content stored in the variables as comments. Okay. That is pretty epic. That's normal. That's really basic beginner stuff. This program prints on the screen the final values of A and B, 7 and 4 respectively. Notice how A was not affected by the final modification of B, even though we declared A equals B earlier. Assignment operations are expressions that can be evaluated. That means that the assignment itself has a value, and for fundamental types, this value is the one assigned in the operation. Hang on, I didn't really fully get that. Let me repeat that. Okay, assignment operations are expressions that can be evaluated. That means the assignment itself has a value, and for fundamental types, this value is the one assigned in the operation. Ah, right, I get it. So this is evaluated and then passed. So this assignment here has a value and then is passed into y. Cool. In this expression, y is assigned to the result of adding 2 and the value of another assignment expression, which itself has a value of 5. It is roughly equivalent to x equals 5, y equals 2 plus x. Okay. The final result of assigning 7 to y. The following expression is also valid in C++. That's weird, but okay. It assigns 5 to all 3 variables, x, y, and z, always from right to left. Okay. Arithmetic operators, plus, minus, that, okay. The asterisk, forward slash, and percentage. Modulo, division, multiplication, subtraction, and addition. Operations of addition, subtraction, multiplication, and division correspond literally to their respective mathematical operators. The last one, modulo operator, represented by percentage sign, gives the remainder of a division of 2 variables. For example, x equals 11 modulo operator 3. Let me work that out. So you're dividing 11 by 3. You have remainder 2. So yeah, results in variable x containing the value 2, since dividing 11 by 3 results in 3 with the remainder 2. Cool. Compound assignment. Okay, compound assignment operators modify the current value by performing an operation on it. They are equivalent to assigning the result of an operation to the first operand. Okay. Yeah, that'll be pretty cool. So, wait, what's the add? Oh, those are logical, is it? No. Not entirely sure what the later ones are. Okay, same for all other compound assignment operators. For example, yeah, that's fine. Increment and decrement. Some expressions can be shortened even more. The increase operator and decrease operator increase or reduce by 1 the value stored in a variable. They are equivalent to plus equal 1 and to minus equal 1 respectively. Thus, plus x plus x plus equal 1, x equals x plus 1 are all equivalent in its functionality. The 3 of them increase the value of x by 1, or of the increase by 1 the value of x. In the early C computers, The three previous expressions may have produced different executable code depending on which one was used. Nowadays, this type of code optimization is generally performed automatically by the compiler. Thus, the three expressions should produce exactly the same executable code. I don't even know how to say that. The thing of this operator is that it can be used both as a prefix and as a suffix. That means it can be written either before the variable name, plus plus x, or after it, x plus plus. Although in simple expressions like x plus plus or plus plus x both have exactly the same meaning, in other expressions in which the result of the increment or decrement operation is evaluated, they may have an important difference in their meaning. In the case that the increase operator is used as a prefix of the value, the expression evaluates to the final value of x once it is already increased. On the other hand, in the case of a suffix, it's used as a suffix, the values also increase, but the expression evaluates to the value that x had before being increased. Notice the difference. Epic. Okay, so relational and comparison operators. Those are fine. Also, I still don't understand how this works, but we'll get there maybe. I need to learn how to do classes first. Operators are fine. I already know most of them. Logical operators, they're pretty epic. I've already shown you one of these, which is that, and that's the OR. When using logical operator, C++ only evaluates what is necessary from left to right to come up with the combined result, relational result, ignoring the rest. Therefore, in the last example, 5 equals 5 or 3 is bigger than 6. C++ evaluates first whether 5 equals 5 is true, and if so, it never checks whether the thing is true or not. This is known as short circuit evaluation. Works like this for these operators. Cool. This is mostly important when the right hand side expression has side effects, such as altering values. Here, the combined conditional expression would increase I by 1, but only if the condition on the left of the AND is true, because otherwise the condition on the right is never evaluated. That's good to know. Conditional ternary operator. The conditional operator evaluates an expression returning one value if that expression evaluates to true, and a different one if the expression evaluates as false. Its syntax is condition result 1 and result 2 with a colon between. Evaluates to 3 since 7 is not equal to... Wait, hang on. If the condition is true, the entire expression evaluates to result 1. Otherwise, to result 2. That's like an if statement, but no, actually no, it's not an if statement. What am I saying? It's kind of different, but still, it's pretty cool. For example, okay, they're instantiating A, B, C. A equals 2, B equals 7, C equals so basically, if A is bigger, assign A to C. If B is bigger, then assign B to C in this case. Epic. So it replaces the needs for massive if statements in those cases. In this example, alright, I already explained this to you. A comma operator, comma, you separate two or more expressions that are included where only one expression is expected. When the set of expressions has to be evaluated for value, only the rightmost expression is considered. For example, the following code would first assign value 3 to b, then assign b plus 2 to variable a. So at the end, variable a would contain the value 5, while variable b contain the value 3. Bitwise operators. Bitwise operators modify variables considering the bit patterns that represent the values they store. What? What is a bitwise operator? I am noob. Help me. What is this? I'm just a noob C# programmer. I am not epic C++ or Cholo Java programmer. I don't know this stuff. Bitwise is weird. Well, in Java it's there, but like no, I think I've heard of it at least, but I haven't seen these. Like, I haven't actually learned it. I mean, I don't know Java that much. So let's see. Okay, bitwise. I'm gonna skip over that just for now. Explicit typecasting operator. Typecasting operators allow to convert a value of a given type to another type. Typecasting. There are several ways to do this in C++. The simplest one, which has been inherited from the C language, is to precede the expression to be converted by the new type enclosed between parentheses. Okay. So, yeah, that's epic. The previous code converts the floating point number 3.14 to an integer value 3. The remainder is lost. Here, the typecasting operator was int. Another way to do the same thing in C++ is to use the functional notation preceding the expression to be converted by the type and enclosing the expression between parentheses. So basically just the other way around. So both ways of casting types are valid in C++. Size of this operator accepts one parameter, which can either be a type or variable, and returns the size in bytes of that type or object. So x equals size of, and then car. Okay, here x is assigned a value of 1 because car has there is a type with a size of 1. The value is returned by size of by a compile time constant, so it is always determined before the program execution. Other operators. Later in these tutorials we will see a few more operators, such as ones referring to pointers or specifics for object-oriented programming. Precedence of operators. A single expression may have multiple operators. So for example that. In C++, the above expression always assigns 6 to the variable x because that the modulus operator has a higher precedence than the plus operator and is always evaluated before. Parts of the expression can be enclosed in parentheses to override this precedence order or to make explicitly clear the intended effect. Notice the difference. Epic. So level, scope, and okay. From greatest to smallest priority, operators are evaluated in the following order. So that is level 1. That stuff is massive. Okay. And then at the end is sequencing. Cool. Here's the stuff that we need. Basic input and output. I mean, we already have it mostly, like, ticked off since it's the fact that we've seen it. Now, this may come in useful. Standard error output stream, standard logging, output stream. Okay, the example programs of the previous sections included little interaction with the user, if any at all. They simply printed simple values on screen. But the standard library provides many additional ways to interact with the user via its input/output features. This section will present a short introduction to some of the most useful. C++ uses a convenient abstraction called streams to perform input and output operations in sequential media such as the screen, the keyboard, or a file. Cool. I've used streams before in C Sharp. They're pretty epic. They're really handy for file writing. A stream is an entity where a program can either insert or extract characters to/from. There is no need to know details about the media associated to the stream or any of its internal specifications. All we need to know is that streams are a source/destination of characters, and that these characters are provided/accepted. Don't want to say that word because I don't know how to say it. I.e., one after the other. Sequentially, I think that makes sense. Yeah. The standard library defines a handful of stream objects that can be used to access what are considered standard sources and destinations of characters by the environment where the program runs. Okay, so we're using standard input stream and standard output stream. So cin, cout, or sin and sout, or kin and cout, whatever way you want to say it. So we are going to see in more detail not only cout and cin, the standard output and input streams, ceer and cerr and clog are also output streams. They essentially work like cout, with the only difference being that they identify streams for specific purposes, error messages and logging, which in many cases, in most environment setups, they actually do the exact same thing. They print on screen, although they can also be individually redirected. We're going to be using logs as well, because that is epic. Because what we can do is one side, we can, just print out your normal sentence, like your narrative of the game, like your RPG, what's going on, and then you can have a logging system where basically it logs what you're actually doing, as in it logs not what you're actually doing, it logs, let's just say we'll make an action log, and we'll make another log as well for the status of the, actually no, we'll just do action logs. Yeah, action logs will do fine. It'll just, provide the user with, what they've done, and then they can, review over it. Why not? Standard output cout. Most program environments, so we've just taken a guess at this, and it works, so we don't really need to do that. It's fine. And okay. Cool, we already know that. Multiple insertion operators, they may be chained in a single statement. This, okay, is a single C++ statement, okay. This last statement would print the text. This is a C++ statement. Changing insertions is especially useful to mix literals and variables in a single statement. Okay, that's definitely useful to know. That's good to know. Assuming the age variable contains the value 24 and the zip code contains blah blah blah, the output of the output of the previous statement would be, I am 24 years old and my zip code is 90064. Okay, 90064. Okay, what cout does not automatically is what cout does not do automatically is add the breaks at the end unless instructed to do so. For example, take the following two statements inserting into cout. This is a sentence, and then cout. This is another sentence. The output would be in a single line without any line breaks in between. Something like this is a sentence. This is another sentence. Okay, that's cool. That's why we use the end line thing. So the end L. To insert a line break, a new line character shall be inserted at the exact position. The line should be broken. In C++, a new line character can be specified as \n. We've already known that. I just use it. For example, blah blah. Okay, we already know that. This produces the following output: epic. Alternatively, the end-L manipulator can also be used to break lines. For example, okay, that's epic. Standard input. In most program environments, the standard input by default is the keyboard. The C++ stream object defined to access it is cin. Okay, that's epic. The first statement declares a variable of type int called age, and the second extracts from the cin from the cin a value to be stored in it. Okay, this operation makes the program wait for input from cin. Generally, this means that the program will wait for the user to enter some sequence with the keyboard. In this case, note that the characters introduced using the keyboard are only transmitted to the program where the enter or return key is pressed. Once the statement with the extraction operation on cin is reached, the program will wait for as long as needed until some input is introduced. The extraction operation on cin uses the type of the variable after the thing operator to determine how it interprets the characters read from the input. So, okay, that's cool. If it is an integer, the format expected is a series of digits. If a string sequence of characters, if a string a sequence of characters, etc. Okay. As you can see, extracting from cin seems to make the task of getting input from the standard library pretty simple and straightforward, but this method also has a big drawback. What happens when in the example above if the user enters something else that cannot be interpreted as an integer? Well, in this case, the extraction operation fails, and this by default lets the program continue without setting a variable for I, producing undetermined results if the value of I is used later. Right. This is very poor program behavior. Most programs are expected to behave in an expected manner no matter what the user types, handling invalid values appropriately. Only very simple programs should rely on values extracted directly from cin without further checking. A little later we will see how string streams can be used to have better control over user input. Extractions on cin can also be changed to request more than one datum on a single statement. This is equivalent to epic. Okay. In both cases, the user is expected to introduce two values, one for variable A and another for variable B. Any kind of space is used to separate two consecutive input operations. This may either be a space, a tab, or a new line character. How long have I been going for? Another 50 minutes. My voice is dead. I've been speaking for more than 2 hours. Well, no, not more, but almost 2 hours. No, actually, it has been more than 2 hours. I've been doing this for 2 hours, and I've only gotten this far. And that too, with programming experience. My throat is dead. Right now, just pressing my hand into my throat, trying to ease the pain, but I don't know if that's doing anything. Just, just pressing it into my... Yeah, there you go, there. That's going to be very weird for you. I don't know, just ignore me. I'm just being an idiot. I'm just doing whatever I want, because right now, I'm not bored, per se, because I actually enjoy learning this, and I actually enjoy making these videos for you to watch, so then, you can also learn alongside with me. Of course, you're probably going to end up skipping a lot of this, but, it's there. It's just me doing me. Just me being me, This is... It's not entirely... This isn't a crash course that's designed to help people. This is just me being me, if you don't like this, then okay, that's fine. If you don't like watching this, that's cool. It's just me reading the documentation. I'm doing this via docs. Like, come on, bruh. I'm gonna keep going for a bit. However, extracting sin... Oh wait, okay. Extraction operator can be used on cin to get strings of characters in the same way as with fundamental data types. Okay, string, my string, cin, my string. However, cin always considers spaces, white spaces, tabs, new line as terminating the value being extracted, and thus extracting a string means to always extract a single word, not a phrase or an entire sentence. To get an entire line from cin, there exists a function called getLine that makes the stream cin as the first argument and the string variable as the second. Epic. Okay. Yeah. That'll prove useful. That'll prove very useful. Notice how in both calls to get into getLine, we use the same string identifier in my string. What the program does in the second call is simply replace the previous content with the new one that is introduced. The standard behavior that most users expect from the console program is that each time the program queries the user for input, the user introduces the field, then presses enter or return. That is to say, input is generally expected to happen in terms of lines on console programs, and this can be achieved by using getLine to obtain input from the user. Therefore, unless you have a strong reason not to, you should always use getLine to get input in your console instead of extracting from cin. Right. Well, let's fix this, shall we? Because we don't want to break this. Let's make this, yeah, okay. So we need to do... Okay. Get line. Flip, how do you do it again? Okay, so it's a method, right. So we're going to be doing cin, comma, I'm going to put a space, comma, I'm going to put another space because I want to keep mine. Wait, does that break it? I don't know. What is it again? Response, is it? Yeah. Okay. That should work. Does that break if I do that? No, it doesn't. Great. Yeah. Let's do that. Let's do that. I'm gonna save that real quick. Save. Can I compile from here? No, I'm just not gonna do that. Next. String stream. Standard header, a string stream defines. Oh my god, my mouth is dead. How do teachers do this? Damn, I have to appreciate teachers now. They speak for like hours on end and without their mouth dying. I mean, to be fair, unless you're just, have a teacher who just be like, okay, this is how you do it now, do like 50 questions. Or, if you're doing one of the arty stuff, like English or languages and stuff like that, and if you get given a bunch of exercises, then that kind of sucks. Well, it doesn't suck because, you have your you're practicing, but your teacher isn't going to be talking too much. But I've been talking for 2 hours straight. My mouth. Yeah, it's 56 minutes. Jesus. By the way, everything I've been using right now is open source, so you can start programming right now if you want. You can just straight up. Actually, I wouldn't recommend C++ right now. If you're a beginner, as much as I hate to say, I don't want you to go straight dig into C++. Because, you see, the thing is, right. I hate to say this, but for the vast majority of the population, Python is the way to go. For the vast majority. As barbaric as it may sound, but Python is the way to go. Because Python, it's a very high level language, which means it's very easy to use and very easy to learn. And it's quite epic. It's an epic language, very good for data analysis. I've already said this before in a Python video, but it's a good thing. However, when it comes to C++, this is also good for machine learning, but it's a very advanced language. Okay, let me tell you this. I'm not entirely sure how Python does it, but when it comes to C++, the language, as you've already seen, you can actually access things about memory. This thing, as in, I'm not talking about normal variables. Variables are used in every single language. But the thing is, you're able to request about the variables. You can request information, not just what it is, but about them, information, their locations. You can quite frankly know relative positions on your RAM. Which means that if you have a program, let's just say that, is running, and then that program asks for its relative position of one of the variables, the OS will return it. And then all it needs to do is, okay, that means I can just increment my memory location of this guy, of this variable, and find another variable from another program, and then corrupt it. It may not be intentional, it may be just completely accidental from a bug. And if you screw something over from your OS by accident, good thing memory is volatile because you can boot it up again, but your system will crash. And if you screw up even worse when you're doing file handling, you may damage a hard drive beyond bootable. You may have to format the entire thing. And if you are a malware enthusiast and you accidentally cause a bug that destroys your own computer, formatting it might not even be an answer, because it might become infectious. It may, as soon as you connect the USB to the hard drive, you may accidentally infect the other machine. It's a very powerful language, you see. It's because of the fact that this language is integrated with your machine. This language, this is, I'm gonna quote Uncle Ben from Spider-Man. With great power comes great responsibility. There you go. It sounds pretty cheesy, I know, but Uncle Bell would be right with this. C++ is a strong language. And right now, you don't really need to know C++. As in, all the base stuff is already being done. If you don't want to handle with it, don't handle with it. Use Python. It's an incredible language. You can use it. Barbaric it may be. It's a good language. Java as well. Java runtime environment is very controlled. You see, you run anything, it's done in the Java virtual machine. Incredible. And then C#. It's done on the .NET framework. You don't mess with anything on the inside. And so yeah, the thing about C++ is that it's a very thoroughbred programming language that requires people who know what they are doing. And that's one of the reasons why it's actually not so popular, because the thing is, it's not that you don't need, actually, it's more like there's only going to be a few people who know exactly what they're doing. And those people are very high in demand. Those people who know exactly what they're doing are very hard to get by, but you don't need too many of them. You just need a few. Because quite a lot of the stuff you're doing is, quite frankly, on top of everything else. You don't need to mess with the basement. C++ be the basement language. It'd be the pillars of everything else. Like your machine right now, if it's running Windows or Linux, it's running C++. It's managing. Except for your iOS users who may be using Swift. Speaking of which, does Swift actually have the same capabilities as C++? Actually, I'll search that up next time. For now, I think I might end this video here. I'll end the video here. C++ is a powerful language, alright? As you saw right now, you've seen right now, I was able to... This file came out of nowhere. You see? I mean, okay, actually no. I mean, I did it via, the terminal, which is fair enough. But I could write a program that, makes a file save. Let's just say a player save. That player save may accidentally end up somewhere else, and it may break my entire system. That's not good. So it's a powerful language. It's very controlling. Ironically, the best game engine available, or at least in my opinion, the best game engine available, the Unreal game engine, runs C++. So if you want to go into game dev, first start off with Unity using the C# language, then go into C++ with the Unreal engine. Alright, see you later. I may just start recording again and go for like another 1 hour. It's 8 p.m. How long have I been here? I'm going to take a break, maybe record again. I don't know what I'm going to do. Or maybe I'll just edit the few videos I have and then chuck them onto YouTube. I don't know.